I'm going to introduce XronoBeat. This is a quite handy tool developed by Andrew J. Milne. He's a senior research fellow of music cognition and computation at Western Sydney University. This software is designed to be a kind of supplementary educational tool for learning music and mathematics together. If you look at the user interface, you can see a big circle. Its perimeter is divided into 16 equal parts. And if you look at the area of the circle, the left half is blue and the right one is orange. On the right of the circle, there's a kind of grid. You can save presets here. Yeah, the overall design is pretty neat, simple, straightforward. I guess it was programmed in Max MSP, which is a really cool visual programming language. Okay, let's see how can we actually produce some kind of music with it. Let's trigger it. Now the clock hand started to rotate and you can hear that each of the 16 dots is associated with a short hi-hat sound, and there's another sound, a kind of rim or knock, triggered exactly at the 8th and at the 16th dot. So what's this whole thing? What does it represent? If you are not familiar with music theory, you can easily approach it from the mathematical side. This is actually a whole number divided into two fractions. 8/16 plus 8/16 equals 16/16, or in other words, 1. In music, that's what we call a measure. This is a single measure divided into beats. In fact, the rim sound represents the counter of the fraction, and the hi-hat sound, which is the beat, represents the denominator of the fraction. So you can see the straightforward connection between musical rhythm and fractions. They are actually the same thing. Now I'm switching to the next preset. You can see that the two halves are divided further into quarters. 4/16 plus 4/16 and 2 more. Alright, these are pretty clear examples, easily understandable, but let's be honest, it sounds a little bit boring. Now I'm gonna show you what makes musical rhythms really exciting. I'm switching to another preset. Well, there is a green slice in the pizza. Why is it green? Let's count the dots. 1, 2, 3, 4, 5. Ooh, this fraction is bigger than the other ones. Our formula looks like 3/16 plus 3/16 plus 4/16 plus 3/16 plus 3/16. Okay, how does it sound? Yeah, I think it sounds better, or at least it's not as boring as the previous one. What I did now is breaking the symmetry of the formula, and that's what makes rhythms really cool. On the one hand, you have a firm, rigid frame with a constant grid. 16/16 is always 16/16. You cannot change it. However, inside this frame you can create unequal parts. You can create an asymmetrical division. Furthermore, you can create parallel divisions as well. You can divide the whole thing with different numbers. Now I'm turning on this second layer and you can see a red rectangle inside the circle. This is the same quarter division I showed earlier, but now I'm using it together with the unequal one. Sounds cool, isn't it? Let's add the third one. So, what makes musical rhythms really exciting is a good balance between symmetrical and asymmetrical division. And of course, you can change the sounds, you can change the pitch, the pan, you have plenty of opportunities. Okay, that was XronoBeat, a really cool educational software. I really appreciate it. Many thanks for Andrew J. Milne. I hope you enjoyed this video. See you next time.